Thank you for standing by. At this time, all lines are in a listen-only mode. Today's conference is being recorded. If you have any objections, you may disconnect at this time. I would now like to turn the meeting over to your host, Mr. Michael Mendelson.
Great. Thank you, Sherry. Welcome, everyone. Today, we are going to present the National Renewable Energy Lab's Cost of Renewable Energy Spreadsheet tool. It's a new tool developed by Sustainable Energy Advantage on behalf of NREL. My name is Michael Mendelson. I am a senior financial analyst with the National Lab, and with me today is Jason Gifford of Sustainable Energy Advantage. We're very pleased to present this tool to you today. We think it's going to be a great balance between ease of use and robust features that will be of particular value to policymakers, public utility commissions, and the like. Before we get started with a detailed model overview by Mr. Gifford, I'm just going to give a very quick overview of efforts by the NREL's finance team and how this fits in. If I could just bring it forward, would be great. Okay, great. So the NREL's finance team activities are sort of broken down into three general areas.
Hi.
Hi. I apologize. No, I apologize. I'm on the with a lot of webinar folks.
Oh, well, okay. I thought should I be on the webinar instead of?
Hi. Sorry for that. So our finance team activities are broken down into three basic areas where we're collecting data and providing raw information to the renewable energy community, developing tools, and conducting policy analysis and visualization of the data and the analysis and tools. Within the area of data, our primary effort is within the Renewable Energy Finance Tracking Initiative, REFTI. You probably have received more than one annoying request for information if you're a developer directly involved in the industry. Our data and connection to the current efforts is available on our website. If you would like to take the survey or the questionnaire, feel free. The current questionnaire is open for Q4 2010, and we definitely appreciate any efforts made to provide your data, and all that data is held confidentially, of course. With respect to policies, we're looking at FITs, we're looking at best practices across the state and regional levels, nationally, internationally as well. So we are looking at FITs, we're looking at tax incentives, depreciation incentives, other things that are used to promote renewables in various ways. One aspect of our tool development is we are adding to Solar Advisor model, sort of the flagship model here at NREL. We are adding advanced financial structures so that developers and investors and others can look at how advanced financial structures, for example, sale-leaseback or partnership flip or other structures can improve the economics of various deals. Back one. With respect to the visualization, the finance team here at NREL has what we call a financial information portal that we can make available, various content as well as the data and the models that will be presented today. So feel free to click through there. The website is down at the bottom left, financere.nrel.gov. And if you have any comments as well, we'd be delighted to hear from you. With respect to the CREST model, this was sort of born from a DOE NARUC partnership. There was a need, as we saw it, for a simple yet robust tool that could look at investment tax credits and depreciation benefits, but do so in a very easy-to-use method. So specifically for policymakers that don't want to go through something more complex like the SAM model. Sustainable Energy Advantage was hired to assess the publicly available tools that are available at the state and regional levels, and also help us design and build a new tool. By looking at the array of tools available, we picked out the best features from other public models. Also, the tools were designed so that you could look at multiple options of input detail that Jason will explain thoroughly. One aspect of this, we didn't want any macros, so we're trying to make the models as easy to use and robust without breaking as possible. And also, we want the models to be able to provide immediate feedback on various inputs. We worked with several states as part of this partnership: Colorado, Hawaii, Michigan, and Washington. We want to extend our thanks to those public entities, and we think that because of their efforts, we were able to offer this great product. The models are available at the following link. You can Google CREST model or look at our financere.nrel.gov home site. That is the full hyperlink there. The models are protected outside of the primary inputs, and we're going to maintain that relationship. We don't want anyone going in and essentially breaking the models and then asking why they don't work or getting an incorrect answer. So we're going to continue to have those password protected except for the primary inputs. We are currently having some issues offering this to Mac users, and we want to thank the several folks that have offered their technical assistance here. But right now, we're not able to offer a Mac version of the CREST tools just yet, but we're working on that and hope to do so within the next week. There is a user manual that was just made available and is up at the site. An analytic report will be offered shortly within the next few weeks, and we look forward to make that available. Both the user manual available now is available at the link at the top of the page. So without further ado, I want to introduce Jason Gifford and really extend our thanks to Sustainable Energy Advantage. We think they did a great job designing this tool, and we think it's going to be a great asset. Thanks. Take it away, Jason.
Well, Michael, thank you very much for the opportunity to work on the CREST model and to participate in the webinar today. And to our participants, I'd like to say hello and good day. This is Jason Gifford of Sustainable Energy Advantage, and I was one of the primary architects of the CREST models that are the focus of today's webinar. And I'm going to provide a brief introduction to this project and the CREST models in the next 3 slides, and then we'll spend the remainder of my time giving a guided tour of the Excel model itself, and then doing my very best to answer your questions. So the CREST models, as Michael began to explain, are actually one of 3 deliverables in a study on renewable energy cost modeling and cost-based incentives in the United States. There is a detailed report which discusses the factors and issues and policy decisions involved in establishing cost-based rates and incentives, and that report will also be publicly available and free of charge, and as Michael said, posted at the same location as the models in the coming weeks. The CREST models themselves are cost of energy analysis tools. So they're intended to assist policymakers and other stakeholders evaluating the appropriate payment rate for a cost-based renewable energy incentive policy. The models aim to determine the cost of energy from a hypothetical generator, where the cost of energy is the minimum revenue per unit of production that's needed for the modeled renewable energy project to meet its investors' assumed minimum required after-tax rate of return. So in the first phase of this work, we created a solar version of the CREST and a wind version of the CREST, and then in a second phase, completed work on a geothermal version of the model. And now all three versions of these are complete, at least in their initial form, and posted for your use at the NREL website. The models share to a very significant extent a common architecture and a common look and feel. This is entirely on purpose so that we can all move freely between the models, learning what we've learned from one and applying it to another. Having said that, the models are customized to the unique needs of each technology. And I think that it's fair and appropriate to say that we do see this as an iterative process, so we are looking forward to your questions as you begin to use the model and your feedback, and we'll do everything that we can to incorporate that in the future. Finally, the CREST models will come with a user manual, and just like it sounds, the user manual provides a guide to understanding and using the Excel file, so it'll provide as an ongoing reference. As you now know, these models were built under contract to NREL. Exeter Associates was the primary contractor, and Sustainable Energy Advantage was the prime architect of the CREST models, and worked extensively with Exeter and Meister Consultants Group on the report. And so we're very grateful for their contributions and participation in the team and the ultimate outcome here. Before turning to the model itself, I'd just like to give you a brief overview of what you're going to see and some of the thinking behind it. We started the model construction process on a couple of key assumptions. First, that the analysis that would be done and the policies that are being considered are cost-based. That is focused on the actual cost to construct and operate a particular generator, as opposed to market-based and focused on what the market value of production is when the generator is operating. We assume also that the policy would be intended to create a fixed payment or an initial fixed payment with an escalation, and that the policy would also be focused on providing long-term revenue certainty to renewable energy generators. So I appreciate Michael's introduction to the topic of our balanced priorities, because this is a key focus of our work both initially and throughout the process. Above all, we wanted these models to be easy to use. Now, having said that, we were not willing to sacrifice some of the more robust functionality around financing and around incentives, for example, and so we found ourselves then also balancing between having a highly automated, macro-enabled solver-type model and one that has these features but is more robust, less likely to have any operating trouble based on the macros or other complex functionality. So you'll see as we go through it that we think we've come up with a reasonably good solution to balance what we hope is an intuitive user interface and still enable without the complexity of macros or solvers to achieve some of the more advanced functionality. The CREST models have enabled the user to designate inputs in a number of categories. I'm not going to go through them individually, but you can see the options there, and it offers considerable amount of detail in many of these categories. We also felt it important that the models enable the user to include constraints related to financing, for example, and ownership, and tax benefits as well. And for example, that is not always feasible or reasonable, particularly at the state level, to assume that that tax benefits can always be used in the period in which they're generated. So we've built functionality around multiple modeling options there. And then finally, as discussed, the output of the model is the cost of energy, and we've also, for convenience and reference, calculated the levelized cost of energy. Now, where there is no escalation in the assumed tariff rate, these two values will be the same, but otherwise the cost of energy will show the year one value, and the associated escalation and the levelized value will be a excuse me, I apologize. The levelized value is the economic equivalent of a single number that provides the same financial benefit through the 20-year cash flow. So now I'm going to turn to the models themselves. We'll start with the solar CREST model. And I'm going to assume that by now that's rendered on your screens, and Michael, you can tell me if you're having any trouble with that. So the CREST model and all the others that follow are, again, set up in the same way, with an introduction and then a series of 5 more tabs, which are ordered in the same order in which they would be expected to be used. And they give an orientation to the model, allow the user to provide inputs, see the summary results, and then, to the extent desired, go through the
Jason, we're actually not seeing the model. Oh, there it is. Great.
That's your desktop?
Okay. The introduction tab provides a quick start guide to the model's use and operation, and it provides an introduction similar to the one I just provided, makes reference to the user manual, and talks about the model setup and a little bit about its operation. We'll talk more about the modeling conventions on the next tab, but it tells you what to expect as you read through the model and what some of the different cells are for. On the Inputs tab of the solar model, I'd first like to talk about the modeling conventions a little bit. All of the inputs themselves are in bold blue, calculated values are in black, and then we have 2 additional features which are maybe not commonplace in a model like this, but we thought were useful. One, we call the check cells, and these appear to the left of all the each input row, and are a red light, green light setup that helps to signal the user that the value that they've entered will operate effectively in the model. Now, one caveat here is that we have not built the model to protect against or to ensure that all of the inputs are accurate within a small tolerance range. We've programmed to ensure that values are included where they need to be included, that negative values aren't allowed except for certain circumstances, and that you don't provide for values beyond what the model can calculate. But otherwise, the users are responsible themselves for researching and validating their inputs. On the right-hand side of each of the input rows is a box with a question mark and a comment in it. And these notes, as we refer to them, provide the user with the ability to roll over the cell and to see a little bit about a description of the input, how we expect it to be used, and then a little bit about the model's parameters or limitations or expectations for the input. So in this example, for the project useful life, a 25-year value is currently entered. You can see the note cell provides a little bit of a description that this model is built for up to a maximum of a 30-year life, and the value entered here must be essentially between 0 and 30. So this is typical of the type of summary and guidance you would find in the note cell. So onto the operation of the model. The last of the conventions here and the first of the inputs for the solar model is a toggle that allows you to choose between photovoltaic and solar thermal electric operation. And really all this does is provide the convenience of not having to convert between AC and DC capacity assumptions. And the remainder of this initial box here is for entering the capacity and operating and useful life assumptions. We get to some of our important and unique functionality as we come down to the capital costs and operations and maintenance cost areas. And I'll talk about these together because they share similar characteristics. The most important thing to point out here is that the user can designate one of 3 levels of complexity. So we thought in many cases it would be helpful to enable users to enter simply one number in dollars per watt on which they'd like to model their project, but thought that perhaps others would like to go to a slightly more advanced 4-category system for entering capital costs, or even further, a complex input scheme, which I'll go over in just a moment, and which refers the user to a designated tab for the introduction of really line-by-line detail of up to 20 lines per category. And we'll go over that again in just a moment. So you can see for this particular example, we've got a project with a total installed cost of about $5.28 a watt. The operating and maintenance section works similarly, with a simple input limited to fixed and variable expenses over the life of the project, and then a slightly more complex version wherein options like insurance, project management, leases, and taxes can be broken out separately as opposed to simply rolled into an assumed single fixed and variable maintenance category. While not a finance grade partnership flip full functionality type of model, the CREST model does enable the user to make assumptions about construction financing and permanent financing, which can include one debt vehicle at the user's discretion, where the term and interest rate and debt service coverage are also user defined. And debt service coverage is one area where we have introduced a very important modeling constraint, and tool for the user, wherein the model will inform you if the amount of debt that you've assumed can be supported by the modeled project at the level of debt service coverage that's been requested. And we'll do this in a little more detail later, but again, using the conditional formatting, we can see that were the amount of debt to exceed that which the project can support, that the model will alert you to that, and using the notes features, walk you through how to make adjustments so that the lender's requirements are met before you make additional assumptions about the tariff rate levels. Summaries of the sources of funding are provided below, as well as inputs related to tax. And here again, looking separately at federal and state taxes, users can make the assumption about whether those tax benefits are used as generated or carried forward, which is extremely important not only in designating between state and federal, but in helping to model different ownership structures, whether it be entirely by a project company or by tax equity investors that may be better prepared to use the benefits up front as they're generated. Moving to the second column of inputs on this tab, I talked a little bit about the tariff rate structure. So again, one of the key premises here was that the policy would seek to provide some long-term revenue stability for the modeled renewable energy generator. And here, the assumption is that the cost-based incentive is for the same duration as the project's life. But that may not always be the case, and this field will allow you to adjust the incentive of the tariff duration to not past the project's useful life, because that would generate one of the errors that we talked about earlier. But it could equal the project's useful life, or in a case where a feed-in tariff or other program was for less than the project's life, that would be reflected in the tariff rate. And then the CREST model would look for an assumption, again, user-defined, for what it should assume for revenue after the tariff expires, but before reaching the end of the project's useful life. And in this case, also, the user will be able to define either a single number with an escalation or designate year by year what that forecast should be. And at this point, I'll jump over to the complex inputs tab because we've now addressed the three instances where this tab would be used. So here, this is the one exception to the entry of inputs. All inputs will be entered on the inputs tab, except for in the case where complex inputs are used, and we would come here. And you can see that four categories are broken out. The first is generation equipment, where the user can define both the name of their entry, the dollar amount associated, the extent to which it's eligible for the ITC, and then using a drop-down menu, choose from one of a number of depreciation classifications to ensure that their project-specific costs are modeled as intended. This setup is replicated for the balance of plant, for interconnection, and for development costs and fees. Reserves and financing costs are calculated based on inputs provided on the Inputs tab. And then here below is a 30-year strip of inputs where the user could define the assumed market value of production, in this case, energy and RECs together, or energy and capacity and RECs as appropriate together for any period after the feed-in tariff or other incentive expires. So returning to the Inputs tab, the CREST models attempt to provide inputs for all of the most common federal and state incentives. So, for example, that's a cost-based incentive like the ITC or the 1603 cash grant at the federal level, or a performance-based incentive, which of course will be more applicable to wind in the form of the production tax credit. Although one could also elect, if some other cash-based performance incentive was available, to include that here as well. And on the state level, similarly, one could model a state-based investment tax credit or either cash or tax-based production incentive if one is available for the particular state of interest. Now, one of the alternative potential uses of this area is to populate this with a REC revenue assumption. By utilizing the performance-based cash payment options, one could now enter the REC revenue as a performance-based incentive, the number of years that's expected to be collected, and any escalation, if any, associated with it. The one caveat I would make with that is that when you then run the model and look at the result of course would be well, a net cost of energy, if you will. You would have already made an assumption for RECs, and the model would then tell you what the remaining revenue requirement would be. Each of the models also allows for capital expenditures during operations. In the case of solar, this might be an inverter replacement. In the case of wind, it might be a blade or gearbox replacement. And geothermal, I'll show you in just a moment, would reflect well replacements. The model also enables some assumptions around reserve accounts, namely decommissioning, debt service, and O&M reserve, with some fairly self-explanatory inputs there. And finally, for depreciation, the model takes into account the current availability of bonus depreciation, although this could be turned off with a yes/no toggle should bonus depreciation no longer be available. Here below is an allocation of depreciation assumptions, which changes along with the capital cost inputs. So here, the intermediate level of detail for capital costs are assumed, and the model then asks you to divide up the depreciation for each category across the corresponding rows. So each row must add to 100 as you allocate the generation equipment across, for example, primarily 5-year makers, but for potentially also some 15-year makers or 20-year straight line or any other configuration, including a certain amount expected to be non-depreciable. And again, these cells, like any of the others on the Inputs tab, allow you to roll over a note which provides some guidance on how the cells should be populated, including, in this case, a reminder that each of the rows must add to 100. So next, I'm going to return the model to a couple of its original settings and show a little bit of the model in use. So after completing inputs on the Inputs tab, you would next go to the Summary Results tab, and up at the top see that based on the current set of inputs and selections made, which are not meant to reflect any particular project at any location, the year one cost of energy in this case is 33 3/4 cents. So if these particular input circumstances represented the type of generator that a regulatory body were looking to encourage the development of, then this might be this would provide some information to assist in the rate-making process. This tab allows you to take, for example, the results from the run that we just did, which provides the cost of energy, the associated escalation up front, a check that the debt service coverage requirements are met, and then the associated levelized rate, as well as some of the basic inputs that go along with that, and to paste the values into one of the scenario columns to the right and name that column, and then one could then return to the inputs, make a different assumption on a project of different cost or other characteristics, return to the summary tab, update the model's assumptions. Let's assume an all-equity project in this case. Okay. And then the debt service is not applicable, but one could then take another set of results and paste those as well for side-by-side comparison and so on. Another set of summary results is provided on the annual cash flows and returns tab, and this may not be useful for all users, but for those perhaps on the project development and financing side that are interested in a little bit more granularity on an annual basis of operating expenses, pre-tax cash flows, some of the state tax benefits or liabilities, we thought this would be a useful reference and summary of the project economics. And it includes a couple of dynamic graphics as well, which change along with the input assumptions. And finally, and equally as important, this is a very open and transparent model. Transparency was another one of the key attributes that we saw here, and so while the cells themselves are protected from accidental deletion, and you will get this type of warning, the formulas are auditable. And clicking on any cell will provide you with the formula path that was used to develop it, and we've done this in the event that it may help the users understand some of our thinking and process. And so here you can go through the derivation of the cash flows and see, in addition, some of the supporting calculations around debt service and depreciation and tax benefits and net operating loss carryforwards as applicable. Finally, just briefly, the way that the model is able to calculate either on its own or by hitting the F9 key without the use of any sort of macros or solvers is that we use a data table system to hone in on the proper result, which it solves within always within several tenths of a cent. And if anybody is interested in a more detailed explanation of that, I'm happy to provide it. But for the time being, I'd like to wrap up with the solar model here and then move over to the geothermal model. So the geothermal CREST, as described, has as much of the same look, feel, and architecture as possible with the solar and the wind. So I'll only focus on a couple of the key differences. We felt it very important that geothermal developments have the ability to use a tool like this to integrate themselves more actively into the policy development and rate-making process. And there are some very particular differences with geothermal development that we've tried to capture here. And so hopefully those users interested in geothermal analyses will agree and find these tools useful. The project performance inputs have been expanded for geothermal to include both degradation at the plant level and the degradation of the thermal resource. So that can be done either by selecting a simple annual degradation value, or in much the same way as we demonstrated with the solar, selecting year-by-year values on the complex inputs tab, which has been expanded to accommodate this for the geothermal model. The capital cost inputs have likewise been expanded. A new section has been created for exploration costs, and here I'd like to point out not only does it accommodate the duration of exploration, but very importantly the success rate assumed in the drilling of exploration wells. So here we have proposed a number of different potential success rate options through the use of a drop-down menu, and what those do is help to include in the total exploration cost those wells that were drilled which did not ultimately reveal a site for further development. So the total exploration cost varies as you make different selections for the success rate assumption. This is further expanded by being able to designate the number of exploration wells and the cost per well. The level of cost detail for the geothermal model works similarly from solar, wherein there is an option just to bring things right back up to the highest level and make a total installed cost assumption, or to go to another intermediate level, which is more robust here than it is for the solar and includes well field and drilling costs like confirmation wells and production wells, and also power plant interconnection and reserve costs. The third option is still the complex inputs option, which operates the same way. Going out to the complex inputs tab, the user can define in 4 categories and roughly 20 lines what their costs are and how they're depreciable and eligible for the ITC. Once we get through project costs, the inputs start to look very familiar again with financing, reserves, and tax assumptions. And the same holds true for the relationship between the cost-based tariff duration and the life of the project. Assumptions on operating and maintenance expenses are a little more robust in detail for the geothermal model, and this is because we felt it important to acknowledge the two fundamentally separate operations that are going on. One is the operation of the well field, and the second is the operation of the power plant itself. A third category allows the user to define other O&M categories like insurance and project management, same categories we discussed before. And switching to the simple switching to the simple designation for O&M cost detail removes that category and allows the user to just roll all of those detailed O&M costs into higher level fixed and variable cost assumptions. As foreshadowed in the solar model, the geothermal model has the opportunity for capital expenditures related to replacement wells, not just one set, but two sets of wells if the user would like to input those at two different assumed time periods over the project's useful life. Again here, decommissioning reserves can be modeled either as funded through operations or from the salvage value of the equipment, which might be a common assumption for a wind energy facility, for example. And then similarly for the federal incentives, we have the same options to select between the most commonly available cost-based and performance-based incentives. The depreciation, both bonus and standard depreciation, work exactly the same way for the geothermal model as they do for the wind and solar model. But there's one final category for the geothermal model which I'd like to highlight that is not present in the other models. And this is because geothermal is unique in more like minerals or oil and gas in its depletion of the resource that need to take that into account. So this area of the model allows the user to work with either depletion mechanism and make their selections for how the resource is assumed depleted for tax purposes.
Jason, questions now? Jason, do you want to take some questions now, or do you want to continue? Now, we lost Jason a little bit. I just wanted to alert everybody that if you'd like to submit a question, please feel free to do so. I see that some people in the Q&A area have raised their hands. We're actually not going to take any voice questions, but feel free to type it in and I'll read it out loud to folks. A number of folks have asked whether or not we can make the slides and the webinar recording available, and that we do plan to do so probably Monday or Tuesday next week. So please look for that. Jason, are you still there? We're working on reconnecting him. Also, people have asked if we will provide the password to unlock the model. No, unfortunately, we're not going to provide the password to unlock the model. Essentially, we don't want people saying that the model is producing a certain result when it's not. So we're going to just allow users to alter the inputs that were designed to be adjusted by the users. Another question was, is CREST compatible with Crystal Ball or other Excel-based Monte Carlo modeling software? I don't know, that's a good question, actually. I'm not sure. I haven't tried at-risk or Crystal Ball adding that on. Maybe Jason will be able to answer that. Are carbon credits considered? There is a place where you could add other costs, but not specifically carbon credits, but you will be able to apply other costs.
Michael, this is Jason Gifford rejoining.
Oh, great.
I was disconnected. I apologize. I hope that only happened very recently.
Yeah, I was just filling in with some Q&A, Jason, so I think it's fine. got some interesting questions about whether carbon credits are considered. Is that something that the user can define?
You know, as a model principally designed to solve for the project's total revenue requirement, no, we didn't. We don't have a extensive functionality around splitting apart the various potential revenue sources. It more typically runs the other way, but it's certainly something we could consider adapting the model to run in both directions and allow you to define more of the revenue inputs.
But if someone wanted to look at the state or utility incentives, is it something they could replicate? Either a carbon credit or a REC revenue?
Oh, most certainly, provided that it was done on a dollars per megawatt hour or cents per kilowatt hour basis. We don't currently have a dollar per ton kind of functionality.
Right. Maybe you want to. Your screen is not up anymore, Jason. Do you want to bring it back up and maybe show the users where they would put that in if they wanted to?
I think provided that your state incentive was able to be quantified on a dollar per megawatt hour basis or cents per kilowatt hours, perhaps in the state incentives as a performance-based incentive, which would be cash and not a tax credit, you could express whether it was taxable, enter the rate here, the number of years that it was expected to be available, any escalation. And then the utilization, which is typically, more useful for tax credits or perhaps, but perhaps could be used as like a discount factor if you entered a forecast but wanted to assume maybe only 90 or 75% of that might be realized. You could use this field in that way too.
Great, thanks. Somebody asked if the instruction manual will be available for download. Yes, it will. It should be up on the site now. So please let us know if it's not, but you should be able to see it now and download it.
And did you provide the address of the site? Maybe provide that again so people know what it is.
Okay, the address would be financere.nrel.gov, and then I believe it's /finance/content/CREST model. But if you go to the main page, financere.nrel.gov, you can see on the bottom right there is a link for the CREST models and other tools as well.
That link is working right now.
Another question, Jason, can REC escalation be negative, indicating a declining REC value?
Yes. So here in this case, we have a assumption for a 2-cent REC available for 10 years, and you, as I judge, you could enter a negative 5% assumed annual escalation, and you see the green check. The check cell is still green, and it allows you to do that. And the note, I was just checking to see if the note also acknowledges the use of a negative value here. But yes, you can most certainly assume a negative escalation.
Right. Will the model be available for concentrated solar power? I guess we didn't mention up top. You take viewers through that. I think we lost Jason. They are having a little technical difficulties, but the solar model is available for CSP as well as PV. Up at the top left of the inputs page, there is a pull-down menu for for PV and CSP.
Yeah, well, Michael, I'm here. I was sort of deferring to you on that. You know, it does have the option for, yes, solar, thermal, electric. I don't, know, maybe some of the potential users could suggest whether we do have all of the appropriate inputs for it to reflect concentrating solar. I'm not sure.
Fair enough. Yeah, I think with relate to concentrating photovoltaics, that would be incorporated by a higher load factor, or higher capacity factor in the inputs page. But there's no specific analysis of concentrated photovoltaics. I'm just going to continue with some of these questions. Do either of the CREST models allow lease sale purchases structured for depreciation tax credit financing? Can you see my question? No, there is no specific sale leaseback analysis or inverted lease analysis. You can, through the model, look at various depreciation schedules associated with capital costs, as well as various tax credit structures, but there is no secondary investor capability to look at a tax equity investor. I mentioned at the top of the hour that we are adding currently that capability within the solar advisor model, or system advisor model as it's now referred to, and that will be available for beta testing within a couple of weeks and should be available within fully vetted mode by the end of April or early May, something like that. So we are working on that, but that is right now only available for the SAM model. Because many users will use default values from the models, where did these figures come from? Jason, do you want to take that one?
Yeah, certainly. We made the conscious decision to provide a populated model so that when it was downloaded, all the functionality would be working. But these are not truly default values that are suggested for use in any particular jurisdiction, because we assume and hope that the models will be used in a wide range of geographies and for different technologies, different project sizes. So we have not endeavored to create default or stock assumptions for different types of projects. We've created the framework and have, at least as far as this project goes, left that research in the capable hands of the users.
Next question, is minimum return on investment included somewhere? Do you want to take that, or would you like me to?
Since we are solving for the cost of energy, yes, the required, the return on equity can be specified here, and the geothermal model, I believe, is where we are. It's on row 77. The user can state the after-tax required equity rate of return. The return on investment is a sort of more general term which takes into account a number of different sources of capital, but yes, return on equity is an input which can be defined in the model.
You went over it quickly, but the model logon for geothermal is slightly different from the solar. What is the new one? Not sure if I follow that. The model logon for geothermal. It should have a very similar look and feel. There are different inputs for capital costs in particular because of the well construction cost consideration for geothermal projects in particular. There was a question before, Jason, whether somebody could use Crystal Ball or another at-risk type of software, statistical software on top of CREST, like they would normally apply to an Excel model. Do you see any reason why that couldn't take place?
That's a great question, and I've used at-risk myself, which is a similar add-in. You know, I would think to the extent that what you're doing is defining parameters for the input cells, that should work just fine. The only potential limitation would be if there was a need to make a change to one of the output cells or create a new sheet or a new area where the output would be generated. The protections on the model might not allow that. Great question. Haven't tested it. I could try and do that.
Does CREST work with ORCs, low to medium temperature geothermal resources? I don't see why it wouldn't, but any thoughts there, Jason?
I suppose this comes down again to a question of whether the inputs are sufficiently flexible to model that kind of cycle. I mean, certainly not. Certainly, we're intending to exclude that. Maybe it would be, if I understand it correctly, just need to be included in the power plant costs. You could use the complex inputs assumptions, and then on the production side, though, across the technology, it's not only for geothermal but for solar as well. And there might have been a question about this. You know, we have not built a model around 8760 production estimates or primary and secondary cycles in the geothermal case. So the production side of that secondary cycle would need to just be assumed in the same capacity factor assumption as the primary.
Great, thanks. What limitations for Excel 2003? We actually have versions for Excel 2007, 2010, and 2003. So please see our website, and you'll see separate links for 2003 and version of Excel. And as I mentioned at the top, we are working on the Mac specific version. I see some people are still having trouble finding the user manual. We'll make sure that you can see that. I guess we're getting an inconsistent view of that. It looks like we can see it, but we will send that a link or make sure that's available. At a high level, what are the advantages or disadvantages of CREST versus SAM? I could start in with that. Maybe, Jason, if you want to add to it. I would say the advantage of CREST is a simpler user interface. There's less detail to get lost in, and therefore, so a little quicker ability to put your incorporate all your inputs that may be relevant to someone that doesn't need the sophistication of SAM. SAM, while being more complex, definitely offers more. Like I mentioned, it will have the ability to look at complex financial structures. There's also a lot more graphical and statistical capabilities available through SAM. Is there anything you want to add to that, Jason?
No, I think that's a great explanation.
Well, this is Carlin Corey at NREL, and I guess I'd just say that there are really kind of two different audiences We were envisioning the CREST tool would be helpful for folks that are not quite as analytical in nature, so public utility regulators, their staff, et cetera. And SAM is really for people who are analysts at heart. And SAM sometimes is intimidating for folks that don't have a technical background, so this provides a nice alternative. The upshot is that here at NREL, we've found CREST as a great way to do some quick and dirty analysis. And because both SAM and CREST were developed here, we had both of the teams that were developing the two models cross-check each other's work in order for them to be as internally consistent as possible. So we hope we achieve that goal.
Great, thanks, Carlin. Another question regarding the market price assumptions. When do they apply? For example, if I enter a 25-year stream of market prices and the FIT applies for 20 years, will the model start using the year 1 market price in year 21, or will it use the year 21 market price in year 21? I believe it's the latter. When you insert the market prices, you're inserting year 1, but the model will pick up year 21 prices in that year.
Yes, that is absolutely correct. So you could choose to only enter the market value prices for the years in which you need them, but we've given you the opportunity to simply enter a current year value and an escalation, and in that case, it'll pick up the market value number in whatever year the tariff lets off.
Great, thanks. Another question: where may we enter business personal property taxes due yearly on a PV system? So property, do you want to show them where property tax is? And they're also interested in insurance costs in the system.
Sure. Well, I've gone back to the solar model. Hopefully it's showing up well on your screen. And you will, in the operations and maintenance section, you will need to use the intermediate level of detail. And we have a line for insurance, which is the input is as a percentage of the total project cost. And then the property tax input is modeled as a slight simplification in an age where, at least for wind projects, payments in lieu of taxes as a negotiated value are more common. This provides you with the opportunity to state a tax rate or really a total tax amount in dollars per year, and then you can adjust that annual tax payment either up or down, or leave it flat. We decided not to calculate taxes based on cost bases and individual tax rates. So although that could be done outside of the model and then averaged into an annual number, which could be input here.
Great. Will the developments you are currently working on for SAM eventually encompass everything that is included in CREST? No, I don't believe so. Well, I mean, you should be able to, any input that is available in CREST is definitely available in SAM. I would say another advantage of SAM is that where there is a single place to input state utility taxes in CREST, there is the opportunity to layer in multiple incentive streams in SAM. So if you have a complex level of incentives at the state utility basis, or SREC or REC prices, or want to look at carbon prices, then in combination with those other incentives, then SAM might be the better tool for you. How does CREST calculate production based on available solar resource? is there an input for location? There is no input for location. Right now, CREST is at a pretty simple level as far as solar production is concerned. You simply put in the megawatt size capacity of the facility, the DC to AC D-rate factor, if we're talking about a PV system, and the capacity factor that you believe is applicable to your location. That is also another advantage of SAM, and perhaps we can add that capability to CREST to be able to look up a location and add that capability. I think that'll be a nice improvement to the model for version 2. For any questions after the call, who can be contacted and how? Thank you. It's a good question. If you have technical questions, then you could come to NREL as sort of a level of first defense for the model. All customization questions and requests can go directly to Sustainable Energy Advantage. We recognize that states and or others who look at the model will be interested in certain customization options, and that is available from SEA. But for other questions, you can come to NREL for that first, and if it's something we can't answer, then we'll go to Sustainable Energy Advantage. Someone has tried using Crystal Ball, and it won't let me without unlocking the cells. So perhaps we could look at that. We're working on password protection now, and that's part of the problem with the Mac version, is that the Mac and the Microsoft versions don't have similar password protection at the cell level. So we're working on that.
Well, and the challenge with either Crystal Ball or At-Risk is those are licensed products, and so we wouldn't be able to provide a CREST model that had it already embedded in it, because we then need to go verifying that everybody that downloaded it had a license for either Crystal Ball or At-Risk.
Right. I assume this gentleman has Crystal Ball.
Right. I'm just saying it's something that we wouldn't. I don't think we're comfortable unlocking the cells for the reasons described earlier by Mike. That I mean, this methodology has been put forth, and you know, if somebody goes in and changes it and says this is what NREL's model says, but they made modifications, that could be problematic. And at the same time, we're not able to, you know, provide a protected version that already includes At-Risk or Crystal Ball. So I think that's a good thing for us to investigate to see if there's a workaround where people who already have that license are able to do it, but that'll take further investigation.
Yeah, we'll look into that further. Next question, please clarify ROI explanation. All we see is IRR output. In a nutshell, how do we display proposed system ROI?
Yeah. Okay. Fair enough. This is a great question. So at its core, this model is designed to answer the question of what tariff rate, what payment, you know, what contract rate does the project need in order to meet, among other things, its investors' required rate of return. So while many models would have you input what's your power price, what's your capacity price, rec price, carbon value, and then it would calculate for you what is the project's IRR, this model runs in the other direction. And so for that reason, there is no IRR output. There is only an IRR input. So perhaps you're seeing maybe in the summary tab, the running IRR, which shows you your progress toward the user's designated target IRR, but you'll always get there by the last year of the project's operation because the after-tax return on equity is an input. And so the model will solve for the contract price that always gets you to that return after having paid for expenses and debt service if applicable. So I hope that that answers the question.
Great, thanks. Somebody asked if there's a model available for geothermal power. There is. We went over that a little bit earlier. If you go to the financere.nrel.gov website and the CREST model page, you'll be able to see models available for geothermal, wind, and solar. Another person asked whether hydrokinetic models will be available or are available. Right now, there is no plan to make hydro or hydrokinetic models available, but we're looking how to make this product available and useful to the broad renewable energy industry. So we'll definitely consider that possibility. Can time of use pricing schedules be included? Yeah, do you want to take it, Jason?
Yeah, sure. Well, that's an interesting question. I mean, if I understand it, it would be another way of asking, could a regulatory body that was considering, for example, a feed-in tariff decide to set the rate on a time of use basis? I would bet that through some modeling using CREST and using some production estimates, we might be able to gain some insights around how you'd set up a time of use tariff. But the CREST models, as they stand now, calculate a single rate that the project would need for all kilowatt hours. There are certainly a number of equivalent on-peak, off-peak, or other time of use values which would end up at that same average value. So one could split that apart externally.
Great, thanks, Jason. I see a number of people have raised their hands virtually in the Q&A section of the webinar. We didn't set up the webinar to take verbal questions, so if you wouldn't mind typing your questions out. I see, though, we only have about 8 minutes left in the webinar. If you have any remaining questions after this webinar, feel free to email me. My email is michael.mendelson@nrel.gov, and I look forward to having a dialogue with you. I'll put my email address in the Q&A section right now. Let's see if I missed any questions. I think we got the bulk of it, but feel free to let me know if I misplaced that or didn't answer your question. I see one question here, Jason. Can you manually enter power production so the tool can be used for non-solar power projects such as biomass CHP? And I think the short answer is you could apply any of the technologies really in any of the models. You could use the solar model for CHP. There may be some details that would be missing, and perhaps CHP would be best applied to the wind model where there wasn't a DC to AC derate factor. But I don't see any reason why you couldn't apply the models to other renewable energy technologies. Do you have any thoughts on that, Jason?
My thought is that almost addressed this question earlier because I acknowledged that we don't have 8760 or other even monthly or annual production inputs. Production is calculated external to the model and entered as a capacity factor. So it sounds like the questioner would like a little bit more detailed input for production than is currently offered. So we can keep track of important requests like that and try and add them in the future.
Yeah. I think that's about it. If there are any remaining questions, again, feel free to email me. And I'll make sure that my email is on there. Somebody just asked, will there be documentation from the presentation available after the webinar? We will make the presentations as well as the webinar recording available to the public, and that will be available at the CREST model website or page of the finance website that we offered before.
Michael, I think there's a question about whether there's a way of telling which parts of the complex inputs tab have been used by looking at the complex inputs tab itself.
Okay, great.
And my apologies if my earlier explanation of that was too fast, but the use of the complex inputs tab is binary. So in other words, you're either all of your cost inputs are coming from there or none of them. If you select, again, we're here now in the solar model, if you select under capital costs either simple or intermediate, all of the costs populate from this input tab. When you select complex, then all of the capital cost inputs populate from the complex inputs tab. So in that case, everything that you've entered here and nothing more will feed the model. And then if you've selected something other than complex, then even if you've left data here, it will not run through the model. So as part of that easy-to-use quest, the conditional formatting here also signals to the user that anything that is shaded out is not being used in the calculation. So you can see in simple, we've got a hypothetical $4.75 per watt installed cost, but when I switch over to another method, even though I didn't delete that value, it is not propagating throughout the model. The same is true for complex inputs. So you're either all in or all out.
Great, thanks.
And so Mike is, he just posted his email address, so everybody should be able to see that on your Q&A to the side. He's also typing in the web address for where you're able to get the model.
Right, yeah, it was the generic, it was the home page for our finance site. I didn't want to mistype the
full thing. Yeah, and in the upper right-hand corner, there's a carousel. One of the main articles there is about the CREST model. There's also a blog that I believe is still on the front page about the CREST model as well.
Right, as well as just a link to the page directly.
And if you can always do a keyword search as well. So many different ways to get there.
Great. Well, I just want to extend my thanks to Jason. It's been, I think, a really fruitful effort and a useful webinar, I think. And thank you, everybody, for attending today. I think we had over 300 participants today, although there were a fair amount of duplicates, but at least 200 unique participants. So obviously a lot of interest in the model, and we look forward to making it available and improving it over time for you. So thanks again, and with that, have a great day.
And to Michael and everyone at NREL, thanks very much for enabling me to participate today. I appreciate it.
Great. All right. Take care, everybody.
Thank you.